Now we're going to do some examples of finding the domains for some multivariable functions. So I have two functions here, and I want to be able to find their domain. So to do that, we need to think about what values are allowed based on this construction. So I have a fraction, and what I know is that the denominator of a fraction can never be 0. So if I look at that, what that tells me is that x can never be 0. So automatically we exclude any value that would have 0 for x. The second piece is I have a square root on top. And if you remember, we can't have negative values inside of a square root. What that tells me is everything inside of the square root has to be greater than or equal to 0. So x squared plus y squared minus 9 must be greater than or equal to 0. And maybe a more convenient way to write that would be x squared plus y squared needs to be greater than or equal to 9. So that tells me x squared, that has to be greater than or equal to 9. And if that were an equal sign, x squared plus y squared equal 9, that would be the equation of a circle. So if we have x squared plus y squared is greater than 9, what that's telling us is that could be, this could be 10 or 12 or whatever. So instead of being a circle of radius 3, it could be radius 4, 5, whatever. So to graph that, what we say is if I think about this circle of radius 3, so 1, 2, 3, 2, 3, and it's not the most perfect circle ever, but that's a dashed circle. We notice we can be every value on that circle except the places where x is 0. And then since we know we can have values that are greater than, anything's greater than 9, it goes on to infinity, except that none of the values where x is 0. So you would shade it in like that. And that's, you could write it with, the set that those things are true. Rigorously you would say, it's the set of all values x, y, such that x is not equal to 0, x squared plus y squared is greater than or equal to 9. And that's perfectly fine. You could write it that way. But a lot of times it's easier to visualize it with a picture. So knowing that, let's go look at one with 3 variables. We have, on top we have this x. Well, that doesn't really affect us, right? That x can be any value at once because it's in the numerator. Now for the denominator, we know that the square root tells us it has to be greater than or equal to 0. But since we're in the denominator, we can't actually be equal to 0 either. So specifically, we have to be greater than 0. So in this case, we'd say 9 minus x squared minus y squared minus z squared must be greater than 0. And with a little bit of algebra, you get that x squared plus y squared plus z squared must be less than 9. So again, if that were an equal sign, that would be the equation of a sphere of radius 3. But it's less than, so we have basically the spheres that are less than radius 3. So again, if I were to draw a 3-dimensional axis, Well, that was bad. All right, we're going to see what we can do here. Then, one way that you can do this, and this is tough, so bear with me, is you draw 3 circles, and then that kind of helps trace out the sphere. And I know that's not perfect there, but the idea is everything inside this dashed sphere, it's not solid because we can't actually equal 9, but everything inside of it. So again, it's not perfect. You do what you can. But the idea here is trying to get a visual understanding of what values relate to the domain.